part is dividing radicals. Last Friday we covered multiplying them. So I want to start with what I like to do as the steps. Step 1, I want you to reduce the fraction. When I say reduce the fraction, that means you're reducing the outsides and you're reducing the insides. Reducing the fraction. Then, step 2, we are going to simplify top and bottom. Step 3, rationalize if needed. Rationalize as if you still have a radical in the denominator, right? And then step 4, simplify again. Because sometimes when you do all that other stuff, you end up having to simplify one more time. All right, so here's the thing. Before we actually get into all those other steps, I need to talk about the rationalizing part. Because you guys have rationalized square roots before, but you've never rationalized something bigger than that. Okay, so let's talk about rationalizing. When we rationalize, we are multiplying by the missing factors. Okay, so when we had like 1 over square root 2, because it's a square root, we needed to multiply by 1 more square root of 2. That simplified it, right? So that way we would have 2 2's inside that square root. So this became the square root of 2 over 2. Okay? If I have 1 over the cube root of 2, I have to multiply by the missing factors to get rid of that radical. So means I'm multiplying by a cube root, but if it's a cube root, how many 2's do I need total? 3 total, right? If I need 3 total, I only have 1. How many more am I going to have to put in the other radical? How many more for a total of 3? 2 of them. So this is actually going to be 4, or 2 to the second. Right? So then I would multiply the top by the cube root of 4, or 2 to the second. On the top, I would have the cube root of 4. On the bottom, I would have 2, exactly. All right, so let's make this even better. What if I had 1 over the cube root of AB squared? Now remember, I have to have 3 of each thing in order to get rid of the radical. So I'm multiplying by the cube root of, I have 1A, so I need 2 more A's. And I have 2 B's, so I only need 1 more B. So then this would become the cube root of A squared B on top, and then there's 1 group of A's and 1 group of B's. Okay, so what if that was a 4th root on the bottom? How many would I have to have of everything? We'd have to have a total of 4 of each thing, right? So we understand that's how the rationalizing works, correct? Yes? If we don't, then I want to explain it a different way. We're okay with that? Okay. Okay. So technically, let me back it up. Technically, we're multiplying these 2 together, right? And so what we just did the other day, if I was multiplying those 2, I would multiply my outsides, multiply my insides. A times A squared is A to the 3rd. B squared times B would be B to the 3rd. So then when this simplifies, it comes out as A and B, and the radical goes away. That's where that came from. Better? Anybody else? Okay, I just want to make sure that before we keep going, because this is like the basics of dividing, you got to be able to do this. Go ahead. Okay, so the whole idea is to get rid of that radical on the bottom. All right, so here we go. We're going to start off slow. What?
If it was to the fourth, then it would be like the one over, the one to the right. You'd multiply by 8 to the third meter.
Yes. Yep. You have to have a total of 4 things. All right, so here we go. We're going to start with example number 1. And we are going to start with simply dividing. And I want to start if I have these square roots of 27x squared over the square root of 3x to the third. So the very first step is to reduce the fraction. So, right, so the 3 cancels with this one and we have a 9. What about the x's? Where do I have more x's? Okay, so the ones on the top are going to cancel, and I'm only going to have 1 left on the bottom, right? Correct. So right now I have the square root of 9 over the square root of x. My next step said to simplify. Is there either of those radicals I can simplify? Okay, that becomes what? 3. So I have 3 over the square root of x. Next we said to rationalize. What do I need to multiply by? Square root of x. Whatever I do to the bottom, I have to do to the top. So on the top, I have 3 square root x. On the bottom, square root x times square root x is x. So these two multiplied together is the square root of x squared. So it just comes out as x. Okay. Let's try another one. Now the problem is every one of these are a little bit different. There's not like a set pattern. Each one is going to be just a touch different. So got to be ready for everything. All right, let's try. Let's try the cube root of 15x over 3y. So technically, we want to reduce that fraction first. So we have the cube root of 5x over y. Now, when they're all inside a cube root, that's the same as saying I have the cube root of the top over the cube root of the bottom. Okay? Can I simplify either of those radicals? No. So now I have to rationalize. I have to use the same dimensions, the cube root, and I have 1y right now. How many more do I need? So it's going to be y squared. Whatever I multiply the bottom by, I have to multiply the top by. So on the top, I multiply my outsides, and then I multiply my insides. 5xy squared over the bottom. When I multiply these together, I get the cube root of y to the third. What comes out? It's just y, exactly, just y. And then you should make sure that you can't simplify it again. In this case, you can't. So any other questions before I go to the next one? Okay, we're doing all right? Go ahead, Jordan. Just like when you multiplied, they have to be the same dimensions in order to divide. Okay? They have to be the same dimensions. All right. Let's get example number 3. Say we have Let's go with the cube root of 48 x to the third y squared over the cube root of we'll just go 6 x y to the fourth. All right, so we've got to reduce our fraction first. 6 goes into 6 once, 6 goes into 8, or 48 8 times. What else? Which x would stay? Yep, so this is gone. We get x squared on top. Right. Get rid of the y's there for y squared on the bottom. So I'm going to rewrite this. I know what I have. I have the cube root of 8x over, or 8x squared, 8x squared over the cube root of y squared. What's the next step? Simplify. Is there something I can take out of one of those? Yeah, so I can actually simplify this top one because there's 3 2's in here, right? I can take a 2 out. So this top is actually 2 cube root x squared over the cube root of y squared. Anybody have a question where that came from? Okay, we just simplified it. Now, if you miss the simplifying step, you can simplify it at the end also. Now we want to rationalize. So I have to multiply by the cube root of what? Just y. Why only one y, Preston? Good. Excellent. All right, so on top, I'm going to have multiply my outsides, I have 2. Multiply my insides, I have x squared y. On the bottom, what do I have? Just a y. It was on the outside, see? I multiplied my outsides, multiplied my insides. Same thing we did the other day. Example number 4. Let's go with, excuse me. How about the, yep, it's a mixture of everything. That's all there is. I mean, so let's go with the cube root of 9x squared y to the third, no, to the fourth, over the cube root of 45x y squared. Okay? Yes, go ahead. Yes.
What if you have like the cube root of 9x squared y to the fourth, and it's divided by something that's not cube rooted?
Then you can't do it.
It's not okay.
Yep, they have to be the same dimensions to divide them. Yep, nope, good question. All right, so we reduce this. 9 goes into 9 once. 9 goes into 45 5 times. Our x's. I have 1x on the bottom. I can cancel with 2 of them on the top. And my y squared on the bottom can cancel with 2 of them on the top. So I currently have the cube root of xy squared over the cube root of 5. See how important it is to go ahead and reduce it before you try and figure out what else is going on? Okay, so now I have to rationalize. So I'm going to multiply by the cube root of what? Well, if I did 5, I only have 2 5s. I need a total of 5 to the second, or 25. Right? Whatever I do to the bottom, I have to do to the top. So on the top, I have the cube root of 25 xy squared over, what do I have on the bottom? Just 5. Exactly. So you guys have any questions? As I said, it just takes practice to try them, but if you go by the steps, it really does make it easier. Okay? So do you want one more example or you want to try some? You want one more example? Okay. Maria, we'll do one more. Example number 5. Let me see what the hardest problem on here is. We'll do something similar. Okay? All right, let's do the cube root of 5xy to the 4th over the cube root of 2x to the 3rd y. All right, so we're going to start by reducing it. Can I reduce my numbers? What about my x's? I get rid of this x on top with one of them on the bottom, right? Okay, what about my y's? I get rid of my y's on the bottom with one of them up here. So I have the cube root of 5y to the 3rd over the cube root of 2x squared. What is my second step? Not yet. Simplify. Is there something I can take out here? I can take out a y on the top, can't I? So I have y cube root 5 over the cube root of 2x squared. Now we rationalize. Okay, so we're going to multiply by the cube root. I have 1, 2. How many more 2's do I need? So 4. And then I have 2 x's. How many more x's do I need? Just 1. Does everybody understand where 4x came from? Yeah. Okay, so whatever I multiply the bottom by, I have to multiply the top by. Cube root of 4x. So on the top, I multiply my outsides and I multiply my insides, which is 20x. The bottom, I have the cube root of 2x squared times the cube root of 4x, which if I multiplied those together, I get the cube root of 8x to the 3rd. What does that simplify to? 2x. Very good. All right, so they start off easy and get a little bit harder until you progress to number 48. All right? You guys got this. On page 371, 37 to 48 all. You got it. I do.